So I know I'm talking about delegates, but I'm going to take a little tangent and just introduce lambda expressions. They're pretty straightforward most of the time. There's some intricacies I'll explore in some later videos. But if you notice here, I had to kind of copy and paste this method here and to get n less than 5, n less than 10, and really this is the most important part, is this n less than 10, greater than 13, that kind of thing. The rest of this is just gibbly-gop. So there's a way we can make this a little more, or a little less painful. We could say a, b, c, just name our function something nice and terse and short and not readable, not understandable. And so I just have to pass a here, b here. But really, we still have the parentheses here, we have the curlies, we have the return. Notice the return kind of repeats. Static, even the return type is the same. I can look at this expression and see, oh, this returns a boolean. I don't have to see it right here. So all this stuff is extra. Alright, so a lambda expression allows us to say, you know what, I'm going to take all this, instead of typing it right here, I'm going to cut it out, and I'm going to paste it right here. So watch, paste. I just pasted a method right there. Now I'm getting a lot of squigglies because this isn't perfect syntax. But if you think about this, static's not necessary. I can infer that it's static. And boolean, again, I can look at this, and this is a boolean, so I don't need the boolean. And really, the method only exists here. I'm not going to call it anywhere else, so the method doesn't really even need a name. And n, we see that n is an int. Well, I know it should be an int because me delegate takes an int. We can infer that here. Me delegate is what I'm passing this method to, and me delegate takes an int. So I can infer that n is an int, so I can actually get rid of that. And I can have the parentheses, but really the parentheses would only allow me to put more than one argument, so I don't even need the parentheses now. See how we're getting down to the nitty-gritty here? And the return, again, I said the return was repetitive. We don't need that. And you know, these curlies here, they're kind of verbose as well. I think I'll get rid of them. And then so on and so forth. Get rid of the semicolon. That's not important. So if you look, all that's really important is the argument name and the expression that's returned. Okay, so C# has a nice little syntax that I borrowed from some other functional programming languages, but basically we just put equal arrow here. Okay, and so n is the argument, and this smiley face, if you want, or this arrow, it points to the body of the method. Right? That's all a lambda expression is. Right, so if I run this, n less than 5, I still get all the numbers that are less than 5 out of our set here. Looks like 2, 3, and 1 are the only ones less than 5. But it's nice that I didn't have to write all that out here. I could just write it right there in line. And I can even see it right there. I don't have to say, less than 5 or whatever. I can see, oh, n where n's less than 5. That's nice and readable. And guess what? If I want to do less than 10, well, I can just replace the 5 with a 10 here. I don't have to have this whole other method up here for it, so I can get rid of that. Or I can do greater than 13 if I want to. So let's just copy this and paste it right here. And then I don't need this extra method as well. So anyway, that's kind of nice. N greater than 13. Looks like 17 is the only one greater than 13. So we get 17. But anyway, that's syntactic sugar. Let me go back a little bit to less than 5. When the compiler sees this, though, this actually doesn't work on a missile level, right? The IL level. But the compiler knows what to do. It just says, oh, okay, you want to do that? Well, I'll turn around and just redo it like this for you behind the scenes. I'll put it up here. The compiler just makes another method for us, just like as if we wrote it before. So that's some major syntactic sugar going on there, that the compiler will do that for us. But that's nice. In fact, just to prove to you that the compiler is doing that, here we go, n greater than 13. Let me get the reflector back up here. Right here, main class. Well, here, let's look at main class. We have a bunch of stuff here. This looks like, oh, cache anonymous method. Whole lot of, we could go into all these details, but I'm just looking for the actual method. A lot of this is generated from the yield, and you can go look at the yield videos on that. But looks like, let's see. I switched over to the C# view, so the IL view is good, but I think in the C# view we can see it. And I also went in here and said view options, changed it to the lowest of low .NET 1.0 C# because back then we didn't have a lambda expression, so it shows us exactly as close as we can get to the MSIL. So if you notice here, we have our yield class as we've seen before, and then I believe over here we have this this method name b __0 in 32. If I click on that, look at that. There's our lambda expression converted right there. So I did make it a normal static method, returns a boolean. You might think that the angle brackets are something special, but they're not. It's just the compiler knows that we can't use angle brackets in our method names like this on a C# level, but it's fine in the missile level, so it takes advantage of that, so it knows that we won't have any name collisions from any of our other methods. Kind of a nice trick. But the thing to take note of is our lambda expression. Let's go back to the original code. Our lambda expression, n greater than 13, it just got converted to a normal method. right? And so when you think of lambda expression, think it's a method. But the cool thing is, it's a method without a name, right? That's why we sometimes call these anonymous methods, even though that anonymous methods are something else in C#. But basically, it's a method without a name. I don't care about the name because I'm going to use it once. It's a one-off. I'm just writing it in this context, so I can use it right here. So anyway, lambda expressions.